Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, I'm going to show you two ways of doing it. The first way would be our normal routine way of doing things, and then the second way, I want you to be able to solve this from a new perspective. So if you use the direct comparison test, so if you look at the denominator, if you add an amount to this denominator, if you let's say if you add 5, then because you're adding an amount to the denominator, then you can say that this will be bigger than this. So if you get 1 divided by that bigger thing, then you can say the overall thing here will be less than or equal to the original thing. But then if you look at this, you know that this thing here is going to converge. So you know that this thing here is going to converge. But then it's useless because if you look at this thing here is bigger or equal to this thing here. So it's bigger. So it's bigger. So it could still converge, or it could diverge. You see, this thing here is useless because we need this thing here to be bigger. You need to be bigger. So if this thing here it converges, then this being lower, we have no choice but to also converge. You see, this as it stands, this being smaller or equal to this thing here converge means nothing. So it's meaningless to add. It's meaningless to add 5 to this denominator. This thing here is meaningless. So an alternative would be to use a limit comparison test. So with a limit comparison test, as n moves towards infinity, this thing here will act as 1 over n to the power 3. So we are going to compare this with the limit comparison test. So when it comes to the limit comparison test, we always need to compute this. We need to get an divided by bn. So we always need to compute this value here. Well, computing this value here would be us doing this. Compute this is your an times the reciprocal of bn, blah blah. Computing this value here gives us 1. So hang on, computing this value here gives us 1. So we know that this thing here is going to converge. Remember, bn is 1 over n to the power 3. We know this is going to converge, therefore this will also converge. I rushed through this because I'm assuming you can do the limit comparison test by now. So the second method from a new perspective would be the second way of solving this would be this. So consider this. Let's looking at the denominator. We are going to use half of this, and why half you will see later on. So for the time being, let's consider half of this. So half of the n to the power 3, because later on we're going to add another we're going to add another n to the power 3, giving us n to the power 3 minus 5. But you see what I mean later. For the time being, let's just consider this. So n to the power 3 looks something like this. n to the power 3 looks something like that. So half n to the power 3 would be slightly fatter. It would be slightly fatter. And then you minus 5, so you drag the whole thing here down by 5, so the intercept will be here. So your graph will look something like this. The point here is that if you consider half n to the power 3 minus 5, your graph will look something like this. So this here is minus 5. Beyond a certain point, this thing here will always be greater than 1. Will always be greater than 0. So for example, at 2 is somewhere here. N moving from 2 to infinity. So beyond 2, you know that this thing will always be greater than 0. So you can actually say that this thing here will always be greater or equal to 0 for sure. So you can make this statement here. This thing here will always be greater than 0 past a certain point. We don't care. We know that the minimum being 2. We know if you put 2 into here, this thing here will always. If you put 2 into here, this thing here will already be bigger than this. So beyond 2, you can be sure that this will always be bigger or equal to this. So now remember, we are trying to obtain this thing here, but at the moment we are considering a half n to the power 3 minus 5. Now, this thing here will always be bigger or equal to this thing here, past a certain limit. And then now add an equal amount to both sides. Add half n to the power 3 to both sides. So you're adding an equal amount to both sides. That will then give you this. So now, hang on. Now that will then give you this. So now let me think. So remember the earlier we had 1 over n to the power 3 minus 5. But if you look at this is the same as this. So we are saying this denominator here is bigger than this denominator here. So hang on. We are saying this denominator is bigger than this denominator. So this number here is bigger than this number here. So if you get 1 divided by a bigger number, then it's got the sign has to switch around. So it's like this. Yeah. So I hope you can follow that. From here, that will then take you to here. So basically, when you take the reciprocal, you switch the sign around. So now this thing here would be bigger or equal to this thing here. Now visualize this thing here as divided by a half. Because if I give you a fraction then divided by this thing here, then you're just going to multiply to the bottom, which is this thing here. So visualize it as this. So that's the same as you multiplying with 2 over 1. So now that 2 here gets multiplied here. This thing here gets multiplied to here. That will then give you this. So now you can see that this thing here, which we know nothing about, we know that it's going to be less than or equal to this thing here. So basically you can do this here. Hang on. This 2 here is a constant, so take it out. That will then give you this. Now we know that this is going to converge. We know that this is going to converge. Now that this thing here is bigger or equal to, then this will have no choice but to also to converge. Okay.